Welcome back. This is the second part of the video. We are still doing the exponents, and now we're going to talk about the addition and subtraction of powers. Remember, we mentioned laws of exponents. In the laws of exponents, we never mentioned addition or subtraction of exponents. We only deal with multiplication and division of exponents, where we said exponent with the same base, you take one base and add the exponents, and then numbers with the same base, when they are divided, you take one base and subtract the exponents. Now let's look at how do we go about adding and subtracting the powers. The first step, you write each base as a product of its prime factor. You write each exponent with its own base, and then you factorize the expression. So it's gonna be clear when we're doing the examples. We're gonna do some examples when we're simplifying. Okay, so let's try and look for an example or something, a question. Yeah, there is an example. We are simplifying 3 to the power x plus 1 minus 3 to the power x minus 1. Okay, let's make it much big or visible. So the question is 3x to the plus 1 minus x to the power x minus 1 over 2 times 3 exponent x. And then the first step from the steps that we previously mentioned is that we must first arrange or to make our bases to be the same. We first make our bases to be the same. The first step is saying write each base as a product of its prime factor. So from the question, our bases are already the same. So we're gonna look at the second step where we write each exponent. We try to separate each exponent. From previous, we said that if we are multiplying exponents with the same base, you take one base and add the exponents. Let's try to rewrite what we just said. Now we are having 3x times 3 to the power 1. That's how we separate our powers. So it's 3 to the power x and times 3 to the power minus 1 divided by 2. You write the denominator as the same because already it's separated. It's 2 times 3 to the power x. Now we factorize. Okay. The next step is to factorize. So when we look at the numerator, our numerator has 3 to the power x and 3 to the power x. So we take the common factor, which is 3 to the power x. If we take 3 to the power x there, it's going to remain 3 to the power 1 and then minus 3 to the power negative 1 divided by, you write the denominator the same. So the denominator and the numerator, there is 3 to the power x, so they cancel. So 3 to the power 1 is 3 minus 3 to the power negative 1 is 1 over 3 divided by 2. You can press your calculator. From the numerator, you will get 8 over 3 divided by 2. And then let's try to rearrange what we have. 3 to the power 8 divided by 2. So 2 has over 1. So when we arrange that, it's 8 over 3 multiplied by 1 over 2. And your answer will be 4 over 3. That is how we add numbers with the same base if we have addition or subtraction. Let's try to make another example. Are we all clear how we did the question? Now let's move on to the next example. It's 4 to the power x. It's 4 to the power x minus 1 plus 4 to the power x plus 1 divided by 17 times 12 to the power x. So the first step, we try to simplify and make our prime numbers, so we know how to press them on a calculator. 4 is 2 to the power 2. 4 again is 2 to the power 2. And then over 17. So 17 multiplied by 12 is equal to, it's the same as 4 times 3. So 4 again is 2 to the power 2 times 3 to the power x. So now let's try to open the brackets from the previous question video. So 2 times x and 2 times -1 plus 2 times x is 2x, and 2 times a +1 it's 2. And then it's you divide with 17, and then when you first multiply the first 2 and then x for the first number, and then for 3 is raised by 1, so 1 times x is 3 to the power x. So that power multiply both 2 to the power 2 and 3. Let's move on. So now let's try to separate what we have. 2 to the power 2x times 2 to the power -2 plus 2 to the power 2x times 2 to the power 2. Then divide by, already in the denominator our numbers are separated. It's just rewrite what we have on the denominator. And then again we factorize. After we separated, we factorize. Again, there is a common factor on our numerator. You take out the common factor, and then you remain with 2 to the power -2 plus 2 to the power 2. And then on the denominator, you just again copy what you have on the denominator. It's 17 times 2 to the power 2x times 3 to the power x. So they cancel from numerator and denominator. On the numerator, you're remaining with 2 to the power -2 plus 2 to the power 2, which is all over by 17 times 3 to the power x. Okay, again, you move on. You try to simplify. So 2 to the power -2 is the same as 1 over 4 plus 4. And then when you press 1 over 4 plus 4, it's 17 over 4. And then 17, the denominator is still the same. Now you try to rearrange your question. Now you have 1 over 17 times, because that's a denominator, and when you multiply what was on the top becomes on the bottom. That is why we have 1 over 17. And then that's your final answer, 1 over 4 times 3 to the power x. That's your final answer. If your answer is negative, try to make it positive. For example, that 3 to the power negative x. So try to make it a positive always. Let's look at the third example. Let's look at our third example. Let's write our example 3 to the power m plus 4, and then minus 6 times 3 to the power m plus 1, all over it's divided by 7 times 3 m plus 2. That is our question. So we have a negative sign on the numerator, so it means that there is a subtraction of numbers with the same base. So there is a separation there. So what we're gonna do, we first separate, and for now it's much easier to separate. So let's just write what we have. Then on the denominator, we separate the 3 to the power m and 3 to the power 2. So again, there is a common factor on the numerator. So it's much of the same thing, because you take out the common factor and then you simplify. So that's how it goes. So now, if you look at our question, there is that 6. We could have simplified to its prime number, but that 6 does not have power m, so we are not interested in simplifying it because there is no power. So that is why we just left it like that. So now we take out the common factor. Now we are trying to simplify, and then the denominator, you just write it as it is. So the next step, you cancel 3 to the power m, 3 to the power m from numerator and denominator, and then everything is fine. You just write what you have, 3 to the power 4 minus 6 times 3 divided by 7 times 3 to the power 2. And then 3 to the power 4 is 81, minus 6 times 3 is 18, divided by, on your denominator you have 7 times 3 to the power 2, which is 63. And then when you subtract 18 from 81, you get 63 as your answer. So it's 63 divided by 63, and then the final answer is 1. Are we all clear? Are we following? Okay, I hope everyone is following. Let's move on and do the last question. So the last question is much different from previous questions. So let's focus and try to understand how to tackle this question. So you have 3 to the power 2x minus 12 times 3 to the power x, and then you have plus 27. So now we are having, okay, you are having 3 to the power x and you are having 3 to the power 2x. Now you try to make that 3 to the power 2x in terms of 3 to the power x. So it's 3 to the power x into the power of 2 minus 12 times 3 to the power x plus 27. Now you have same 3 to the power x. Now you can say let m, any number, be equal to 3 to the power x. So in place of 3 to the power x, you write m. So it's m squared minus 12m plus 27. Now you can factorize because now it's something that you know. M factors of m squared, it's m and m. So the last value there is positive. So my signs are going to be the same, and then the middle term is negative, so it's negative negative. So now you go back to what you said. Endaweni eno-m you write 3 to the power x, and then you just simplified your question. So it's how you do